Now this illustration deals with overcurrent devices rated 800 amps or less, in accordance with NEC 240.4b as in boy. And basically, as the 29 amp calculation, we rounded up to the 30 amp device. But if the ampacity of the conductor happened to be 28 amps, this 240.4b would also let you round that up to 30 amps. Now, if we're over 800 amps, then we're going to see in 240.4c as in car, you'd have to round down. But we could apply 240.91b as in boy, and we could apply the 95% rule. And the 95% rule, say if you had a 1,000 amp of conductors, this is an example, take 91% of 100, and then that'd be 950 amps, and if your conductors matched 950 amps or less, you'd round it up, so not less, but over. You could round it up, but you'd have to follow the requirements of 240.91b. Now, those are the three concepts where you either round down, round up, or apply the 95% rule. Now, with this thought in mind, let's review the NEC loop together. So 210.20a deals with the overcurrent protection for this circuit. 240.4b allows the roundup. 240.4a1 through a2 deals with this overcurrent protection scheme. And 110.14c1 little a deals with an overcurrent device at 100 amps or less terminated to conductors number 14 through number 1 based upon 100 amps or less. So now let's review the illustration and see just exactly what we're talking about. Now, step 1, the load is a 90 amp, as you see in the illustration. So we will take 125% of 90 amp in accordance with 210.19a1a. 125% of 90, though, is 112.5 amp. Now, 110.14c1 states we could use the 90-degree column insulation, say THHN, but we'd have to terminate it at the 75-degree or 60-degree column after derating based upon where in the 110.14 C1A or B did the device fall. Now, in step 2, we're looking at 75-degree C terminals because it's a 112.5 amp calculation. So the calculated load is 112.9 amp, or 112.5 amp. But the connected load is 90 amp. Now, step 3 is the golden rule to determine the load. 310.14A3, informational note 1, item 2, and table 310.16. And notice the 112.2 amps, they're using a number 2 here. I'd like to point out that some inspectors would require this to be pumped up and increased to a 1/0 because of the requirement that if it was over 100 amp, it would be 75-degree C terminals. If it was 100 amps or less, you could use 100 amp or less type overcurrent device. Now, just the opposite, some engineers and inspectors say, no, step 1 is just a 90 amp load. So based upon the connected load, not the calculated load, we would allow the number 2 to be used. I would suggest very highly that you check with the authority having jurisdiction, with state, county, or city, whoever that authority may be, and check how they would exactly review this rule in 110.14C1A or B. Now, if permitted, then note 4, looking at a 115 amp device, you could round up to 125. But when this is done to have overload protection, then usually there's a second stage of protection required because you're rounding that up to a pretty large device. So either in the equipment you'd have fuses or a thermal protector or some kind of second stage of protection to protect the conductors and the equipment, but the overcurrent device would allow full usage of a number 2 conductor at 115 amps. And notice a number 2 conductor selected at 115 amps from table 310.16 would very definitely supply the calculated load of 112.5, and the 125 amp overcurrent device is considered protecting connected load, calculated load, and the roundup size of the device. So the solution, the answer is the size conductors at number 2 THWN copper could be used on a 125 amp device based upon a number 2 being good for 115 amps if the authority having jurisdiction will allow the number 2 to be used and not required to be 1/0 based upon the size of the overcurrent device being over 100 amps.